Okay. Can you see the screen?
Yes, sir.
Okay. So today we start with a new topic, and that is phase controlled DC motor drives. Okay. What is the meaning of phase control? What do you mean by phase control? Anyone? Vikram, what is the meaning of phase control?
Sir, hello.
Sir, hello.
Let Vikram answer. Subhajit.
Okay, sir.
Vikram.
Sir, something sir related by sir phase.
Something related to phase. So we are changing the phase angle of the phases. Subhajit, you
Sir,
can say now.
So with the help of phasor, to control the turn on and turn off characteristics of thyristor, it's called a phase.
Turn on and turn off characteristics. No, you don't change the characteristics. You turn on and turn off the SCR.
Turn on,
to control
It's
the.
a firing angle control.
It's a firing angle, sir.
Yes. Firing angle control. Phase is short for phase angle control. And you are controlling the angle at which the phases are connected to the load. Okay, we are controlling the angle at which the phases are connected to the load, and the load in this case is going to be a DC motor. Okay, we have already seen in the first part of the subject, we have already seen what are the applications of DC motors. We have already seen where DC motors were preferred, what are the advantages of DC motors, what are the disadvantages of DC motors. Even though we want that induction motors should be used everywhere, we still see a lot of DC motors present in variable speed drives because it is very, very easy to control the speed of a DC motor. Okay, we've also seen the types of DC motors, and we've also seen the equations for a DC motor. Correct? What are the equations? So as we already know, the back EMF of a DC motor is proportional to flux into speed. So if we replace the proportionality sign by an equal to sign, you have a proportionality constant K multiplied by the flux phi and the speed omega m, or omega in radian per second. Similarly, we also seen that the motor torque is equal to K phi Ia, where Ia is the armature current and phi is the flux per pole. And the applied voltage V is equal to the back EMF plus the IaRa drop. Okay. We have also seen that the motor speed omega, that is equal to V upon K phi minus Ra upon K phi Ia. Correct? Or it is equal to V upon K phi minus Ra upon K phi whole squared multiplied by the motor torque. Okay?
Yes, sir.
So this is the equation for the speed of a DC motor. And any general DC motor, we have, these are not for shunt or series. These are for every DC motor. The speed omega is equal to B upon K phi minus Ra upon K phi whole square multiplied by the torque, where V is the applied voltage, K is a constant, phi is the flux per pole, Ra is the armature resistance, T is the motor torque, I is the armature current. Okay, till now we had assumed that the motor applied voltage is constant. But now, because we have started studying phase controlled DC motor drives, that means we now have a variable voltage DC supply. Okay? Or in other words, we can change the value of V now, we can change the value of phi. We can also change the value of RA. All three things are under our control. So, based on this equation, what are the different methods by which we can control the speed of a DC motor? Yes. Based on this equation, what are the different methods by which we can control the speed of a DC
So
motor?
field control and field control and
Sir,
voltage control of
resistance
armature
control, sir.
means
Sir, external resistance
Resistance
control.
control, voltage control.
both are resistance control of armature. Three methods.
Okay, the three methods are available. The first one is by controlling the armature voltage V. The second method is by controlling the field flux phi. And the third method is by controlling the armature circuit resistance RA. Okay. RA is the armature resistance. We'll have to insert an additional resistance. So let us say R is the armature circuit resistance, that will be equal to RA plus the external resistance. Out of these three methods, which method is the best?
So armature resistance control.
Armature resistance control. Okay, anyone else?
So depend upon the application, if you want to increase the speed, then flux control that. If you want to decrease the speed, then hold armature resistance.
Correct. That is the right answer. There is no such thing as a best method. It all depends upon the applications. If you want to increase the speed above the rated speed, you go for flux control. And if you want to decrease the speed below the rated speed, you can either use the armature voltage control or you can use the armature resistance control. However, armature voltage control is preferable over the armature resistance control because
Efficiency will efficiency will decrease.
losses efficiency decreases in the armature resistance control. Okay. So the speed torque characteristic. Again, we are starting with the DC shunt motor. So we have already seen that these are the speed torque characteristics of a DC shunt motor. Okay. Now I'm assuming here that this is at rated voltage, rated flux, and without any external resistance in the armature circuit. Is that clear? The speed torque characteristic is at this speed torque characteristic is at rated voltage, rated flux, and without any external resistance in the armature circuit. Now, suppose I have the facility to change the applied voltage, applied armature voltage. Okay. What will be the change in the characteristic? First of all, it has to be very clear that when we are changing the voltage, we will keep the flux constant. Okay. Clear? When we are changing the voltage, we will keep the flux constant. And when we are changing the flux, we will keep the applied voltage to the armature constant. Okay. That means you will have, or I think instead of DC shunt motor, we should say that these are the characteristics, or we are studying separately excited DC motor. Okay. So you have two supplies, one for the armature circuit and one for the field circuit. And both the supplies are going to be controlled independently. So when we are controlling the armature voltage supply, we are not touching the field supply so that the field flux remains constant. And when we are changing the flux, we are not touching the armature voltage controller so that the armature voltage remains constant. Of course, if you want to control the field flux, your field circuit also needs a rectifier. Okay? Because without rectifier, you cannot change the voltage. Okay? So if you want only armature voltage control, you need voltage control only in the armature circuit. But if you want field flux control also, then you need voltage control in the field circuit also. Okay, so coming back, this characteristic that you see, this one, this is the speed torque characteristic of a separately excited DC motor at rated voltage, rated flux, and without any external resistance. Now what happens if I change the applied voltage while keeping the field flux constant and without inserting any external resistance? What will happen?
So no load speed will change.
No load speed will change. The no load speed is given by V upon K phi. So as soon as we change the value of V, the no load speed changes. How much does it become? Does it come here? Can I bring the no load speed here?
No, sir, we should not increase than rated voltage, sir.
Correct. We cannot increase voltage above the rated voltage. That is why we cannot shift this characteristic upward. We can only shift it downward.
Downward, sir.
Okay. Okay, so I cannot increase voltage above the rated voltage, and hence I cannot increase the no load speed above the rated value. I can only bring it down. So let us say I decrease the voltage, and this becomes the no load speed. Okay. How will be the characteristic then? Will it be parallel to this
Sir, parallel, sir.
characteristic?
Yes, sir,
Why
parallel with
parallel?
this, sir. Sir, no
Why
change in
Yes,
parallel?
the
slope, sir.
parallel. Slope change.
Sir,
No
There is
change
no
slope
in
depends
slope.
on flux, sir.
Yes, the slope depends on Ra and phi, and both of them are being held constant. So because there is no change in slope, the characteristic will be exactly parallel to this characteristic. Okay, everyone?
Yes,
If
sir.
I decrease the voltage further,
Yes, sir.
the characteristic keeps on shifting downwards. Okay, this is the characteristic with increasing value of voltage.
Voltage.
Okay, and of course you cannot go beyond the rated voltage. Okay, any questions here? What are the advantages of this method, armature voltage control? First advantage is that
So by control,
the efficiency,
by controlling the firing angle,
the controlling,
we can vary the armature voltage as our required.
by controlling the firing angle, we can change the armature voltage to any desired value, and hence we can obtain any desired value of speed. Okay? That is one thing. It is a stepless control. Correct? What do you mean by stepless control?
Sir, smooth control.
Smooth control, or you can get any value of speed that you want.
Yes, sir.
You know? Of course, if you are using a rectifier, if you are using a transformer with taps, then it is not a stepless control. But if you are using a rectifier, then by changing the firing angle, you can have any value of speed that you want. Okay. Another advantage is that the efficiency is high. Okay. Good transient response, good speed regulation. Okay. The speed regulation is good. The disadvantage is that you can get speed control only below the rated speed. You cannot control speed above the rated speed. Okay.
Okay, sir.
Okay. Suppose I want to increase the speed above the rated speed. First of all, can I increase speed above the rated speed?
Yes, sir.
Can I? Yes or no?
Yes, sir. Yes, sir.
Anybody who says no,
Yes, sir. Yes, sir. Yes, sir.
how high? Suppose
By
my
changing the field.
rated
By
How high?
field quantity, changing
Increase
the flux.
by decreasing the field current.
What question I am asking and what answer you are giving? Do you
Sir,
think I
up to
am
which
speaking
percentage,
broken
sir?
English? How high? I'm asking how high you can increase the speed.
Sir, maximum speed of the machine.
So what
150%.
what is the maximum speed of the machine? Suppose the rated speed of the machine is 1000 RPM. Till what point I can increase the speed?
Sir, 150%.
1000, 150%. That means I can go up to 1500 RPM. Kalyani, how much the speed can be increased?
Mm, No, sir, I don't.
You don't know. Okay. Bhanu Prakash, how much the speed can be increased? Can it be increased above the rated speed or not?
Yes, sir.
Yes. So how high? 150%, 200%, 300%, 500%,
150%.
150%. Okay. Sumit,
Yes, so we can we can have a higher speed application beyond its rated speed, 150%, sir.
150%. Priya, what percent?
So I will not say. I will not answer the questions.
That is the right answer actually. If you don't know the answer, you should. And to all the others who are saying 150%, if you don't know the answer, you should say so. And tomorrow, if you go in an interview and you say 150%, why 150%? Why not 200%? Sumit, why not 200%? What is stopping
Sir, I
you
don't know.
from going up to 200%? What is stopping you?
Sir, the motor may damage, sir.
Sir, I think it will be specified in the nameplate.
Yes, but what are the factors that determine?
It's a mechanical strength of the shaft.
Yes, correct. It is
Mechanical
not the
strength.
voltage. It is not about electrical parameters now. It is about mechanical considerations. Okay? How much speed your motor can handle, that depends on the mechanical considerations. Okay? So in DC motors, it is normal that you can have maximum speed up to 2 to 2.5 times the rated speed. How much? You can go up to 2 to 2.5 times the rated speed. If you want more than that, then by increasing the mechanical components, you can say you can have greater speeds also. Okay, is that clear? Yes.
Yes, sir.
Yes, sir. Yes, sir.
Okay, so how high your speed can go, that is solely dependent on the mechanical considerations. Normal motors, you can go 2 to 2.5 times the rated speed. If you want even greater speed, you can improve your mechanical components and you can have greater speeds also. Okay. Okay, so once again, I've drawn the speed torque characteristic under rated voltage, rated flux, and without any external resistance. Now, I want to increase speed above the rated speed. Now that we've already seen that this is not possible by increasing the voltage because we are already at rated voltage. Okay. So the next option is we can change the flux. And the advantage is that the flux here is in the denominator. So for going above the rated speed, we do not have to increase the flux, we have to decrease the flux. And when it was at rated flux, the field winding was already supplied with the rated voltage. That is why this field flux method cannot be used to obtain speed below the rated speed. Correct? So if you want to
2 to 2.5 time in all type of DC motor.
Hmm.
In all type of
Okay.
DC motor.
Depends
Okay.
on the mechanical ठीक है, mechanical considerations, how, who is making, which manufacturer is making, ठीक है, local manufacturer possibly you may not be able to go above 1.5 times also, so it all depends, ठीक है. So where was I? To obtain speed above the rated speed we have to decrease the field flux, ठीक है. And how do you decrease the field flux? By decreasing the field circuit voltage. Okay, clear? So if I decrease the field flux, what is the change in the characteristic?
Sir, both no load speed and slope will change.
Yes, the no load speed also changes and the slope also changes. Okay, so these are the characteristics with variable field, है ना? This is the direction of increasing field flux, or the opposite direction for the decreasing field flux. Okay, how much flux can you decrease? Theoretically, if you make the flux zero, then speed becomes infinite. So can you go up to infinite speed?
No, sir.
So residual flux.
Residual flux. Okay. Still, how much flux you can decrease? कहाँ तक जा सकते हैं?
So you are saying, so speed you want to, you can increase up to 2 to 2.5 times. So we can decrease the flux, means at the same proportional, we can decrease
ठीक है.
2 to 2.5 times.
Suppose I have the facility of increasing speed about 2.5 times also. Okay, I'm using very high quality materials, so I don't have any limit. So how much I can decrease the flux?
In the same proportion, we can decrease our flux.
So you can make the flux zero if I have the ability to run at infinite speed.
You are saying we can means this is the facility we are having, that we can increase the volt, we can increase the speed, means above 2.5 time, means near to 2.5, means more than 2.5, but it is not so much high, means it is not infinity. It is means
So suppose I can increase it up to 5 times, 10 times. Then what? Okay. You
flux.
have, Priya Malhotra, you have got one point and now you are thinking only with respect to that point. Okay. Whereas I have left that point a long time ago. Okay. So the question is, how much can you decrease the flux? Anyone else?
So till it is in the linear region without going into saturation.
No, if you are decreasing the flux, there is no question of saturation now. Anna? If you are increasing the flux, then it might saturate. But if you are decreasing the flux, how can it saturate?
Okay, sir.
Yes, anyone else?
So negative of the residual flux.
Negative of the residual flux. It means we are saying negative flux. How can you get negative flux?
I mean, we can decrease up to 0 and still there will be residual flux. And if we decrease further in the opposite direction, then the residual flux will also decrease. So the motor will not start.
Okay. All of you find the answer to this question. Tomorrow's class, I will start from this question. Okay? How much can you decrease the flux in a DC motor? Okay? Everyone, I'll name anyone and ask.
Yes, sir. Okay, sir.
Yes, sir.
Okay. What is the disadvantage of this method or limitation of this method?
Cannot go beyond rated speed.
You cannot go below rated speed. And you cannot decrease speed below the rated speed. Okay. We also have the option of controlling speed by changing the armature resistance. So once again, if this is the characteristic at rated voltage, rated flux, and without any external resistance. Now, if I insert external resistance in the armature circuit, what happens?
So I square losses. I square
The
losses.
slope will change.
Yes, as far as the characteristic is concerned, the no load speed will remain.
Same, sir.
Oh.
Hello?
Hello,
Hello?
am I speaking to Dr. Amir?
Yes, yes.
So this is Joint Register Academy, who I speaking.
Okay.
Is it right time to talk to you?
Actually, I'm in a class. Can I call back in 15 minutes?
Okay, after you take your time and please call me.
Okay, okay, sure.
Okay, thank you.
So where were we? If you change the armature resistance, there is no change in the no load speed. However, as you go on increasing the armature resistance, this slope is going to keep on increasing. Okay? So, as you go on increasing the armature resistance, this is the characteristic with increasing R. Is this clear?
Yes, sir.
Yes, sir.
Okay, everyone. What is the advantage of this method?
Sir, loss.
Advantage, Baba. Loss is not an advantage.
So only by changing the resistance we can achieve the
Controlling is
control.
easy, sir.
It is very simple.
Controlling is easy.
Controlling is very simple. All you have to do is connect an external resistance and you have to change the resistance. You can change the speed. No need to study power electronics. No need for any power electronic devices. No microcontrollers, microprocessors. Nothing is required. Okay?
So high torque
You
can
can
be gained
control
in the
manually.
starting. Sir, high torque can be
You
gained in
can
the starting
control.
with the help of high resistance in armature circuit. So high starting
Okay,
torque.
Priya, I will come to that. So you can control manually. If you want to control it automatically, then you can control automatically also by using some microprocessors, microcontrollers also. Okay, Priya, who told you that by increasing the resistance you get higher value of torque?
So higher starting torque in the DC motor we can get in the starting means resistance. We are putting the high value of resistance in the armature circuit and then gradually we decreases the resistance as our speed maintains means come to steady state means we gradually cut out our
How
armature
how
resistance.
how increasing the resistance will increase the torque?
So torque is increased by actually DC shunt in case of DC shunt motor uh, torque is proportional to IA, field is constant, and uh, IA means
And
sir,
IA
sir
is
1 minute.
inversely proportional.
1 minute. Uh, so so IA is torque is proportional to IA, and IA means V minus N upon RA. So torque is inversely
IA
proportional.
is V minus N upon RA. How did you
Uh,
get this relation?
um, so speed is proportional to E by phi. Speed. Sorry,
IA
sorry,
is
sorry, sorry,
equal
sorry.
to
Speed is constant. Speed is proportional to E. So speed is proportional to E means V minus IARA. So IA that means V
IA
minus
is
N,
equal to V minus E
N
upon R.
V
IA
minus
is
N,
equal to V minus E upon R. V
V minus
minus
N
E,
upon V
everything
minus N,
divided by R.
V minus N upon RA.
No, no,
So speed is proportional to
no. If you are taking speed, there is a flux also there.
so in case of DC shunt motor, I'm saying.
ठीक है, clear your concepts first. I'm also talking of DC shunt motor only. IA is equal to V minus E divided by R. IA is equal to V minus E divided by R. So if you are increasing the value of R, your armature current is decreasing. So how will the torque increase?
So by sir, that's why
ठीक है. Think about it. Think about it.
E plus
Somebody has told you that by increasing the rotor resistance of an induction motor, you can increase the value of torque,
Yes, sir.
and you are applying that everywhere.
Yes, sir.
ठीक है?
Yes, sir.
Yes, yes, sir.
Okay, so if I draw a graph between the maximum allowable torque as a function of speed, how will that graph be? Acha, before coming here, we have seen the advantage of this method. What is the disadvantage of this method?
So I square are lost. I square are lost.
Yes, sir. Less efficiency.
Yes. As per our law, this method is highly inefficient. This method is highly inefficient. Earlier, when we could not change the applied voltage, we had no other option but to use this method. Okay? Earlier means 20, 30 years ago, 40 years ago, when power electronics was not as established as it is today, and we did not have converters, we did not have SCRs and all those things. At that time, there was no other option, so this method was used for the speed control of DC motor. But now this method is never used unless it is a very low power application. Okay? For example, if you are using, I'm just giving an example. I'm not saying you use DC motor in a fan. Okay? I'm just giving an example. If for your home fan you use a DC motor, which method will you prefer to control the speed? Will you go for armature voltage control or field flux control?
Resistive control.
Yes, because it is a very low power application. Okay?
So now triac is used, sir.
It does not justify. It does not justify very low power applications. Do not justify going for armature voltage control or field flux control. Okay? अरे बाबा, we are talking of DC motor and you are saying triac. कौन था ये पनाक था शायद? Triac is used for DC control.
No, sir.
I'm
Actually,
just giving an example. If you use DC motor for small applications, there is no sense in going for either armature voltage control or field flux control. Okay? Very small applications in watts. Okay? However, if for kilowatts, megawatts, then this method will, will prove to be very cost ineffective. Okay? So, unless your application is very small, you do not use armature resistance control anymore. Okay? Am I clear?
Yes, sir.
Yes, sir.
Yeah. Okay. Okay. So, if we draw a characteristic between maximum allowable torque and speed, how will that characteristic be? Remember that torque is
Straight line, sir. Straight line parallel
proportional
to
to flux and IA.
straight line parallel to X.
Straight line parallel to the x-axis. Till this point. What is this point? What is this point?
Base value of speed, sir.
Correct. Base speed or rated speed. Okay. What happens after this value?
Because the field control method.
the field control is going to be used. You are going to decrease the flux. So after this, torque simply, this will be the characteristic after the rated speed. This characteristic is at constant torque, and this one is at constant क्या है?
Power, sir.
Power.
Sir,
Because
the
both your
question.
voltage,
Sir.
your voltage
Sir,
and your maximum. Yes, yes.
the question you asked before, the sir question, so the answer is the up to constant power, up to where the constant power is maintained by the DC motor, and that
Flux,
up to that speed,
flux,
flux can
flux
be
wala.
decreased. Yes, sir.
How much you can decrease the flux? I asked. 1%, 2% of. Take a suppose your rated flux is 100%. So how much can you decrease it? Till where can you go? 1%, 2%, 3%, 5%, 50%, 70%. How low can you go? That is the question. Okay, Subhajit?
Yes, sir. Yes.
Hmm. Okay, so this here you have armature voltage control. Okay, that means you are changing the voltage, you are keeping the flux constant, and your maximum allowable current is also constant. So you get constant torque. And after this, you are decreasing the flux. So you get your torque is decreasing, but your voltage and current are being held constant. So now this is at constant power. Okay. Similarly, if you draw for maximum allowable power, okay, maximum allowable power, then how will be the characteristic? This is the characteristic, constant torque. Okay, and after this, constant power. Correct? Because here you are increasing the voltage. So your power is increasing. Here after this, you are keeping both the voltage and the current constant. So you are getting constant power. Okay, you must have seen these characteristics before, constant torque and constant power. Have you? Yes or no?
Yes. Yes, sir.
Sir.
The thing is, these are maximum allowable torque and maximum allowable power. Okay, actual will be different. Because actual torque or actual power will depend on the load.